Welcome to this Taiwan Semiconductor video. TSC enters the automotive LED market, the LED driver market. We're actually doing this with a current regulator. This is actually an industry standard IC on the market already for many years. Taiwan Semiconductor second sources it. It comes actually in a SOT23 package that is fully compatible with everything else on the market. But actually we're manufacturing this in CMOS rather than bipolar. And actually we're going to discuss some of the advantages of doing so in this video. So it's easy to design with these products. We all know they're very reliable, and there's actually no EMC. The unique selling points of this series are its ease of use and actually also the low cost. CMOS actually brings further advantages in this area, as well as better accuracy. You can also bring some technical advantage here, especially when strings are paralleled. The efficiency of this type of product can be lower, but it depends on the supply voltage and the number of LEDs that need to be driven. Let's go ahead and look at some of the details here on this slide. We're offering the full range of it. There's 2 high side and 2 low side control ICs. We're having, of course, all the obvious current settings, 0.1, 10 and 20 milliamps. Furthermore, we're aiming this at automotive, so it's obviously AEC-Q101 qualified. The product is PPAP capable, and of course, the temperature ranges from -40 to 125 degrees C. All the advantages of a CMOS process will also interest, actually, I think, non-automotive designers. Let's look at it and visualize it. It's easy if you look at this circuit diagram. Of course, in the CMOS version, it's the voltage reference that is used for accuracy. In the bipolar version, it's the VF of the diodes that is used for as a reference. The CMOS version is obviously going to be more accurate than the bipolar design. Actually, the CMOS process may also be more modern and more cost-effective, actually, in 2020. You got the same pinout on the package, so that you can do a drop replacement in actually the circuit. Let's now look a little bit more at how this is done. Of course, we've got the 2 high side control ICs where the PNPs are replaced by P channels, the 2 low side control ICs where the NPNs are replaced by N channel transistors in the circuit. If you look at the CMOS advantages, they come out here, of course, a very good temperature coefficient versus output current. And of course, we're going to also have a very good, output current regulation when actually the voltage is going to change. CMOS has one thing we should be mentioning. Of course, CMOS IC will have an Esd rating. That really shouldn't be such a big problem because actually LEDs are also very sensitive to Esd. The datasheet is actually a copy of the bipolar version, but if you're going to look carefully, you'll see that it's not just the same, but there are also some minor differences. Obviously, the enabled currents are going to be lower. CMOS is going to be, you have less standby currents than other ICs. The rest of the IC, the V drop spec looks the same. What the difference is going to be the difference in regulation. 2 parameters where you're going to see a major difference is, of course, the output current versus temperature regulation or changes over temperature. And you're also going to see that the output current is going to be much more stable versus the supply current, and that this value is also significantly lower than bipolar. Let's put them side by side. Here you can see on the left, you can see the CMOS specs. On the right, you can see the bipolar specs. Obviously, the CMOS specs being much better. This then results in, if you compare the curves in the datasheet, this is actually for a 55 milliamp circuit where you put an external resistor of 20 ohms to get your 55 milliamp. You can easily see the CMOS version. You can vary the voltage and nothing will change. You can also change the temperature and it looks pretty stable. The bipolar version, well, it's around 55 milliamp, but obviously there's quite a bit of variation in this type of circuit. Let's compare the quiescent currents. Obviously, the CMOS version is always going to be have the lower quiescent current. It's also a little bit less dependent on the voltage than maybe bipolar. And obviously here you have advantages side by. Let's look at the V drop voltage. If you look actually here, you can see that the really with the right angles and that type of stuff is always the CMOS versions. The one with the rounded characteristics are obviously the bipolar versions. It's going to be much more difficult to reach the exact regulation when the currents are higher. With 6 ohm, you're talking about a higher current. With 6 ohm is in parallel to the internal resistance, and actually you can see that the differences or the advantages of the CMOS circuits are higher with higher currents. Of course, this V drop regulation that's very accurate makes it easy to choose your external resistor. These are typical circuits here you see on the bottom to increase the current. Otherwise, we should also mention, of course, that the IC has a negative temperature coefficient, so there's no thermal runaway, or there's no risk of thermal runaway. You always have to watch out for power dissipation in the IC when there's a big difference between the VCC and the LED string current. It has to be dissipated in the IC in this case. And here you see on the left-hand side, on the low side control, you see that you can actually increase the current by paralleling devices. The best way to think about the advantages of this CMOS version is to imagine 304. We showed the 55 milliamp graph through slides before this. It is actually to think 304 LED strings in parallel. Of course, in the CMOS version, they are going to be much better matched than in the bipolar version. So you're not going to see any differences in brightness between the LED strings. Dimming is going to be quite similar. You can interface the IC, the low side IC, with the microcontroller, and obviously here you see from the graph immediately see that's fairly linear. So you get a 60% duty cycle on the PWM signal will result in a 60% output current roughly. So let's summarize. Of course, you have with the CMOS version a higher accuracy of the output current and a low quiescent current. The V drop is controlled by the CMOS voltage reference, and that actually gives you much more stability of your output current and easier to choose the external resistor. And it's got a very good and low negative temperature coefficient. We've actually also made a spreadsheet for you to help you design with this product. It's easy, but there are a couple of things to watch out for. First and for all, the difference between the power supply and the LED string voltage has to be at least 1.4 volt to keep the IC in regulation. The second thing is, of course, that if the power dissipation can be too high, if the voltage of the difference between the VCC and the LED string is fairly high, it has to be dissipated in the IC. The power output dissipation, or the total output dissipation, is of course also dependent on the PCB layout and the thermal resistance of the PCB. And the last thing, of course, that you need to be able to calculate is the resistor you need to put in parallel of the internal resistance to increase the current. Thank you for watching this video. If you want more information about our products, you can see the web links on this page. Thank you.